I'm sure a lot of you are curious about 3D printers, especially because you can just create something out of nothing. And of course, with that comes the ability to model, the ability to problem solve, to fix things that are broken, plenty of other stuff that you can use a 3D printer for. So they are very useful. I thought I could give you an intro on some of the basics that go along with them, just so that you can be a little more familiar for if you decide to shop for one later on, some of the things you should look for, you know, stuff like that. So of course, the first thing you need is a program for making your 3D models. Here I have SolidWorks because this is the one that I am just familiar with using, so I got that one. You can see this part here is a filament holder bracket because when I moved to New Mexico, I accidentally broke mine, so I need to make another one. So in this case, once you're done making your model, so you go to export and you save it as an STL because this is the file that the printers read. So that now saved it into my Google Drive and it is currently uploading onto my printer computer. So let's go over there and see what's happening in that room. So here we are in the printer room. I got mine here in this nice little box. I'm printing ABS, so I have it in this sealed box. That way all the toxic fumes don't get out. Of course, most of the filaments create toxic fumes, but some more than others. You can see my spool is just sitting there on the floor because the thing broke off, so I need to make another one. Your printer will have its own controller program. Mine's an X5X, so it came with a program called Repetier. So I will go ahead and get that running. You can see once you open it, it shows your build space. So mine is 13 inches by 13 inches by, I think, 15 inches. So you can see our little cube of build volume that we have. That way you don't try and print anything that's too large for it. So the first thing you need to do is heat up your hot end and your bed. Depending on what type of hardware you have, these can either take a short amount of time or a long amount of time. Mine is only a 24 volt system, so it will take a little bit of time to warm up. So you can see in these settings, I have my bed set to 105 degrees and my hot end is set to 255. I will wait because the hot end takes a lot less time to heat up than that one, so I'll let that go. This is for ABS plastic, which needs to be in both of those ranges around. Each printer differs, but mine seems to print good at those, so I'll take with those. Of course, not all printers come with a heated bed, but the heated bed makes it a lot easier to print stuff. So when you get one, you want to look for one that has a heated bed. Of course, they're going to be more expensive too, so it's a trade-off. As far as the two temperatures go, when you get your filament, it will usually have a sticker on the side that tells you what your nozzle temperature and your bed temperature should be. And then you start with those and you just kind of adjust it up or down, depending on if it worked good or if it didn't work good. So you'll see this is a lot of trial and error when you start working on these. Like I said before, this is a Tronxy X5. So this is a Core XY printer. So the hot end does the X and Y axis and the bed is in charge of the Z axis. So this one comes as a 2-post. I put the 2 extra posts in to make it a little more stable when it moves up and down. So if we go back over here, I can click on the 0 button and it will home all of the axes. You can kind of watch it work in real time when I click. You can kind of see the bed moving. The bed moves the slowest, obviously, because it has the most fine adjustment. So we can now go import our file. So here's our part that we saw earlier. Now I just need to adjust its position. So we'll go over here and rotate. And it is ready to go. So the next thing you need to do is use your slicer, which these all come with built-in slicer programs. Cura is the one that I use because it works okay, but there are plenty of others you can use. Depending on what program you have, they come with whichever. You also have to put in all your different settings in this one. I have mine on ABS settings, which comes with all these different things. You'll have to read up online the definition of what all of them does when you adjust them. So it is a lot more complicated than it looks initially. But this one I already have all the settings made, so all I have to do is click the slice button. And what that does is it builds your tool path for the part. I think it's loading right now. Did it work? No. There we go. There. So now it disappeared and it comes back as this little thing with all these lines, and it shows you your build path for the whole thing. It also gives you how much filament it'll take and your estimated time. You see the bed's almost there. It takes a while. You can buy better beds if you have coin. Those ones heat up in like 5 seconds. I just haven't gotten one yet. You can watch this one really jumps up there with the temperature. So that one, I don't even have to turn on and wait for. For all intents and purposes, I'm assuming your printer is ready to go right out of the box. Some of them require some adjustments and fine tuning before you can actually start working on them. Like this one has a manual bed. So that means you have to adjust the height of it yourself for it to actually get a good level print surface. Others automatically do that, which is nice. Of course, mine is cheap, so it didn't come with that feature, but some of the newer ones do. I'll now hit the print button now that it's warm and show you how everything works. You can see that little straggle of filament left on it because once it heats up, it starts to just kind of ooze out by itself. And now you can watch it in real time building your profile. You can see the outline is not really cooperating right now, which means my bed is not as high up as it should be. You can see how it's doing perfectly now after I restarted it without touching anything. So that just goes to show that these are very temperamental when it comes to wanting to print. Also, depending on the kind of motors yours comes with, they're pretty noisy. This one likes to make music as it's going. With that being said, once your first few layers are down good, then it is pretty much good to go for the rest of the print. Hopefully. Sometimes it likes to die mid-print when it's making some of those complicated structures, but that's something else to get into. Yeah, I told you this one's loud when it's going. Makes music. So here is our finished piece. A word to the wise. I don't suggest pulling this off immediately after it's done because one, it's really hot still because of course from earlier the bed was at 105 degrees. That's Celsius, by the way, so that's 5 over boiling point of water. And two, it's gonna be stuck. And if you try pulling it off immediately after, it's not gonna wanna come off. And you run the risk of breaking it too, which I've done that before, so take it from me. Oh, and lastly, because it's at 105 degrees, that's the glass transition temperature for ABS. So when you peel it off, it's gonna be like really bendy, and then it's gonna harden in that distorted shape, and you won't actually have the shape that you printed. Now we can kind of go over some of the parts that you'll see on these printers. You can see we have our fan up here. That top one is the part cooling fan. You can see that goes into those two fang ducts and they blow directly on the nozzle there. So when you have a part that needs to print at basically extreme angles like 90 degrees, it'll blow air on it. That way it can cool the filament faster. The other fan in the center is your actual hot end cooler. That one needs to be running all the time. Otherwise all the heat will go up the hot end into the filament and it will melt prematurely, and then it will clog the hot end and you won't actually extrude anything. So you want to have that fan running. That way it only melts in the area where it's supposed to. Your other motor is your extruder motor. That one's hiding in the corner down there. That one is basically just a sharp geared tooth that digs into your filament. You can see that the filament is just a big spool of basically string made out of plastic. So all it does is it digs into that and it pushes it through this plastic tube, which goes into the nozzle. The nozzle is heated up to 255 degrees, so the plastic melts. It gets pushed through the nozzle hole, and then it draws the path, and that's how you get this. The other stuff you have is just your basically drive motors. So you've got an X and Y motor there, and then you have your Z motors on the bottom. Depending on where the motors are is based on whatever brand you have, so they're all different. This one's also a little bit modified, so it doesn't look the same as the normal Tronxy printers. But other than that, that's pretty much all your basic stuff. So our controller hardware is here. We have our main board. This one is not wireless, so I have to plug in via USB if I want to print. That's why I have the computer dedicated to this. So some of them have features that have wireless printing, which you definitely want one of those because it's more convenient. You can see this one has a MOSFET to control the bed. The bed has its own dedicated power supply too, because the bed draws a lot of amps, so it needs its own. We can go into our actual print settings here. So you see we can control the feed rate for the filament motor. We can control the part cooling fan. You can't control the actual hot end fan because that one just needs to be running at a constant speed to keep the heat coming off it. And then you can control the temperature of your bed and your extruder. So depending on your filament, you can change those up however you want because each type of filament requires its own specific temperatures. For the actual slicer settings, you have, of course, your profile, any type of adhesion you want. So you can look up the definitions of each one of these for what they mean. But adhesion is basically sometimes your stuff doesn't stick on the bed as easily. Like ABS is very finicky when it comes to sticking. So you can put in certain types of adhesion assistance, which I have mine working pretty good. You saw my bed was kind of hazy earlier. That's because I put glue down on it so it'll stick better. But you can add in like a brim or a raft support, which puts in these little like flat things that go on the outside so that it sticks easier. Your quality is basically just your layer height. So if you want it to be more jagged on the Z-axis, then you can make that taller and it'll also print faster. And then supports are for if you have any overhang. So if you're printing stuff that isn't just straight vertical, you can add supports in to help it so that it doesn't bend. That's also what the part cooling fan is for. And you can also change your speed for how you print. Core XY style printers print really fast, which is nice. And then the infill density is just how much you want the inside to be. So if you make that 100%, it'll be just rock solid plastic. And if it's 0%, then it'll be completely hollow inside. So I think that gave you a pretty good understanding of all the basics for it. You'll find out soon enough that there are probably 10,000 different variables that all change and all affect your print in one way or another. So good luck working with it. It's a lot of trial and error. Feel free to join a forum of people that have your same style printer because they all already went through it and they probably have the answer for you.